Okay, I love these problems. So the way I describe what's happening here is we've got two secants, okay? And part of the secant is on the outside of the circle, okay? So we're talking about this first secant here, so I'm just going to put a little subscript 1. While the entire secant, I was going to say secret, right? While the entire secant, let me color that in. So there's the entire thing in blue. That's the whole secant. So you've got part of it on the outside. Whoops, that's the first one. You've got part on the outside, and then you've got the whole thing. And then over here, you got the same thing happening. You've got an outer part, that's for the second secant, and then you've got the whole thing. So the whole part of the second secant. And we're going to be talking about the lengths of the segments that are made here. And we've got the outside of the first one times the whole length of the first one. Let me write this here. If this happens, if you've got two secants with a circle, and they meet at a point outside that circle, the outside times the whole is equal to the outside of the second secant times the whole length of the second secant. So the outside times the whole equals the outside times the whole. Here we have a secant and a tangent. So here we have the outside of the first secant. And then, of course, we have the whole thing. So we'll call that whole. And that's of the first line. And they meet at a point outside the circle. And then we have the second one, which happens to be a tangent. But it has an outer part too. And it also has a whole part. And that whole part happens to be the same length as the outer part. But that's okay, because the formula is still the same. The outside of the first part of the first line times the whole length of the first line is equal to the outside part of the second line times the whole length of the second line. So let's put these into action, and you'll see what I'm talking about. The outside times the whole equals the outside times the whole. So the outside is 6. So that's the outside of the first one. And we're going to multiply that by the whole length. So the whole length would be 6 plus 8, which is 14. So I have 6 times 14 is equal to, now we're going to do this again, the outside is 7. So the outside part of the second is 7. And the whole length of the second part is 7 plus y. So I'm going to have to put that in parentheses, 7 plus y, since we can't add 7 and y. And I'm going to have 6 times 14 equals 7 times 7 plus y. 6 times 14 equals 7 times 7 plus y. If you are a little bit ahead of me, you're probably distributed, you're multiplying 6 times 14, that's fine. I notice that I can divide both sides by 7 and not have to distribute, and then 14 divided by 7 is 2. So 6 times 2 is 12. 12 equals 7 plus y. Y is equal to 5. And we're done. Okay, so let's try another example. Here we've got a secant and a tangent. Same rule applies though. We've got outside times the whole. So the outside is 7 times the whole thing, which is 7. I'm sorry, I keep saying 7 and it's z. The outside is z, the whole thing is z. And that's going to equal the outside of the secant, which is 8, times the whole thing. Now, if you go too fast, you might say 16, but it's not 16. It's 8 plus 16. So I've got z squared equals 8 times 24. And 8 times 24 is the same thing as 8 times 8 times 3. And the reason I'm doing that is because I'm going to square root both sides, and now z is equal to 8 times the square root of 3. So that's just some cool arithmetic there. Some very, very cool arithmetic. Okay, let's go ahead and try these two. So I think that now that I've given you an example of each, outside times the whole equals outside times the whole, you're ready to try these two problems and see what you get. And then come on back and check your answer. So on this first one, if you got x equals 55 over 4, you're probably ready to move on and see what the next answer is. On the next one, I got x equals 7 over 2. So those are my two answers. So if you're good with that, you're done. If you need a little bit of instruction, I'm going to do that for you. 14 times 14 plus 20 equals 16 times 16 plus x. Now I don't want to multiply 14 times 14 and 14 times 20. That's just a lot of work. So what I'm going to do, I can do 14 times 34. I guess I could do that. Yeah, let's do that. 14 times 34 equals 16 times 16 plus x. And I'm going to divide both sides by 16. I'm going to take a chance here. So 2 goes into 14 7 times. 2 goes into 16 8 times. 2 goes into 34 17 times, and 2 goes into 8 4 times. So 7 times 17, so I've got 7 times 17 over 4 equals 16 plus x. 7 times 17 is 119 over 4. And then I'm going to subtract 16 from both sides. And I'm going to put that in terms of fourths. So 64 fourths is going to be 16 equals x. 119 minus 64 is where the 55 is coming from. So x equals 55 over 4. Next one, I've got the outer part is x and the whole thing is 6 is equal to the outer part is 3 and the whole thing is 7. So 6x equals 21. Divide both sides by 6. This is a very common fraction for students to forget to reduce. So that's how we got 7 over 2. Most excellent. Okay, in the next video, we're going to talk about one more rule. We're going to practice it and we'll be done. We'll be done.